Today we're going to talk about some of the phenomena of wave interactions. The first one I want to start with is fixed end reflection. If we take a look here, we have a string, and I'm going to send a single pulse through that string. And I want you to notice what happens when that string reaches a fixed end, a stationary point. So we're going to send one pulse, and we see this pulse travels through, and as it hits the end, it bounces down. And that's only going to be true if there's a fixed end here. It'll bounce down and turn around and flip. That's going to occur anytime there's a fixed end. When you have a fixed end like this, you could have multiple pulses. I'm going to produce a second pulse in a second here, and we're going to notice that these two pulses interact. If we look at these two pulses, they interact in the middle here. And briefly, for a second, if you noticed it, they disappear. This is called destructive interference, and I'll try to pause it to catch it. Look at how almost nothing there is here. Destructive interference is one possible phenomena of what's called fixed end reflection. Fixed end reflection is when a wave bounces off and sort of comes back to where it started. Superposition is a form of interference where two waves go through the same point and they interact with each other. In constructive interference, we have the two waves both on the same side of the line, and they build each other. You add their amplitudes when they come together, and then they continue to go in their merry way. If we look at the lifestyle of this one wave right here, well, this wave right here moves to the right, it builds with the other wave briefly, has a bigger amplitude, and then goes along on its merry way. No problem at all. This is constructive interference, where they build up, and the total amplitude is the added amplitude of the two waves. Here on this side, we have destructive interference, where this wave and this wave are on opposite sides, and we'll notice here that they subtract. In destructive interference, you subtract the amplitudes, and again, if we look at this wave only, it again goes off on its merry way as it was before the interaction. Same with this wave, destructive interference, and then continues to do whatever it's already doing. In problems like these, we can see that these two would destructively interact, and it would produce answer 2 here when you subtract them. And if we look here, A and B, well, this would be constructive interference. And when they came together, they would add. So they'd have a total amplitude of 0.3. But then after they passed through each other, they would go back to their initial amplitudes, which is why the answer to this question actually would be the same as the initial amplitude, which is answer 2 here. Let's go back into our wave on a string and notice what happens if we do multiple waves oscillating. And take a look, it's going to bounce off as expected and immediately interfere with itself. And let's take a look at what happened to our amplitude of this wave. The amplitude doubled. The amplitude is the combined amplitude of the two waves at some points. And then at some other points, you have nothing happening at all. Take a look at right here, this point right here. Oh, and I accidentally introduced a wave to it, so I'm going to have to pick a new point here. But let me restart that oscillation. We have this passing through, it's going to reflect, and it should start to double our amplitude as it passes through. We see our amplitude doubling at what is called an antinode, and the amplitude canceling out completely at what is called a node. Let's look at this point right here. I'm not going to click it, but we're looking at the point where my mouse is. This has an amplitude of 0. And, oh, well, then we added more to it. That brief amplitude of 0, I'm going to look at a more static simulation of this. That amplitude of 0 right here is where the two waves cancel out, and this is called a node. Then there are other points where the two waves don't cancel out, and you see a maximum amplitude, and this is called an antinode. And you could think anti for amplitude, A for amplitude. Antinodes have max amplitude, node have no amplitude, no for node. So no amplitude at a node, max amplitude at an antinode. And this is what's called a standing wave, a repeating wave that occurs over and over and over again. That's fixed end reflection, constructive and destructive interference, and standing waves. We're going to build on that together, and that's it for now.